In this question, we have a small company repairing and reselling broken cell phones. They order a case of 256 iPhone X screens. We have 3% of the screens may be cracked and sent back for a refund. And it says the 256 screens are independent. Now, once again, let's go through our rules for binomial distributions. Number 1, we have to have a yes or no question to answer. In this case, we can say that our question is it broken or is it not? Because the subject of this problem is whether or not they may be broken. Number 2, we have to have a fixed sample size. We do because we know there are 256 screens to check. We have to have a known probability of it being broken. This probability is 3%. Number 4, each test has to be independent. It says in the last line that they are independent. So we can use a binomial distribution to model this, and that means it's also okay to use the formula binom.dist.range. Let's remind ourselves of what goes inside this function. We have the sample size, n, that's 256. P, the probability of the screen being broken, that's 3%. We'll have to enter a low value and a high value. Now, in this question, they tell us that 5 or less of the screens are cracked. So 5 or less means the highest we can go is 5. So here's our number line. Starting at 0 and ending with 256, the number in the size of the sample. However, we want 5 or less. So 5 will be part of the answer, and everything less than that will also be part of the answer. So we can say that our low value is 0, and our high value is 5. Now, let's make our list in Excel. We'll have N, P, low, and high. Based on that, we can get the probability of X being less than or equal to 5. We'll type 256 for N, 3% for P, low of 0 and a high of 5 as we drew in the picture. And now we enter binom.dist.range. We'll click on the number of trials first. That's 256, comma, 3%, comma, 0, comma, 5. With all 4 pieces of information entered, we press enter, and we say the probability of having 5 or less of the screens being cracked is 0.218. Question B asks, what is the expected number of screens that will be cracked? When they say expected number, really, they want the mean. Now to find the mean, that's just going to be N multiplied by P, the size of the sample, times the probability of it being cracked. Now, we already have the N and the P entered, so we'll come down one line and make a field for the mean. So, for the mean, we'll say equals, click on the N, multiply, now click on the P, and press enter, and we get 7.68 for our mean. For the standard deviation, we have a different formula. We'll say equals square root of N times P times Q. We'll add one more line below for Q, and we'll say that's automatically 1 minus P, giving us a Q of 97%. So just remember, Q is your probability of failure. That's 1 minus P, while P is your probability of success. In this case, a success would be finding a broken screen. So now down below here, we'll make an entry for the standard deviation. We'll say equals SQRT. We will click on N multiply P multiply Q. When we press enter, we get a standard deviation of 2.7294. For problem D, the question says, when the case arrives, the owner of the repair company counts and finds that 16 of the screens were cracked. What is the probability that 16 or more screens are cracked under the original assumptions? Once again, we'll draw a picture. The lowest we can have is 0 and the highest is 256. However, we are just interested in 16 or more. So 16 will be part of the answer, and we're going to go more than 16 also. So everything to the right will also be part of the answer. This gives us a low value of 16 and a high value of 256. As before, N is still 256 and P is still 3%, as with the previous problems. Let's make our entries, and we can find the probability of X being greater than or equal to 16. N will be 256, P will be 3%, the low value will be 16, and the high value 256. Once again, we will use binom.dist.range. And once again, the order is N, P, low, high. So we'll type that into this box. Click on the N, comma, P, comma, low, comma, high. Close the parentheses and press enter, and we get 0.005. In Part E, the company owner returns those screens for a refund as he's angry that so many of the screens were cracked. He accuses the manufacturer of lying about their defective rate. Is it reasonable for the company owner to think that the true rate of cracked screens is actually higher than 3%? For this, let's refer back to the previous screen where we have our mean and standard deviation. Our mean is 7.68, and our standard deviation is 2.7294. If we want to find if a value is significantly low or significantly high, here's what we can do. We can say our significantly low values will be the mean minus 2 times the standard deviation. And our significantly high values will be the mean plus 2 times the standard deviation. So, let's make a little more room and find the significantly low and high values. For the low value, we'll say equals the mean, subtract 2 times the standard deviation. Click on the mean, minus 2 times, now click the standard deviation, giving us 2.22. The significantly high value would be equal to the mean again, now plus 2 times the standard deviation. When we press enter, we'll have our significantly low and high values. Now, let's make a drawing based on this. Now, our significantly low value is 2.22, and the significantly high value is about 13.14. Now, in between those, you'll have most of your bell curve. However, you also have the tails of the bell curve, starting from 0 and going to 256. The person in this question had 16 defective screens. That is definitely more than 13.14. And so since that's on the right side of the graph, we can say that is significantly high. We can also say it would make sense if the person who got 16 defective screens would think that the failure rate for these screens is higher than 3%, because he got a lot more than the mean. He has 16 broken screens, where the mean is 7.68. He's so much higher that he's considered significantly high. Now, similarly, it's possible that someone got either 0, 1, or 2 broken screens might think that the defective rate is lower than 3% because almost all of their screens were good. However, most results are going to be in between 2.22 and 13.14. So anybody who got 16 broken screens would be quite reasonable to think that perhaps the failure rate is higher than advertised.